Okay, just wanted to share with the community some of the discussions that have been going on amongst the agencies that participate in ISEG, and there's a little bit of discussion here about some of the NASA-specific activities regarding exploration of lunar volatiles. So next chart, or I guess I can do that. So I think everybody knows what ISEG is, 15 space agencies, and one of kind of the ad hoc projects or activities in ISEG we've been undertaking for the last three years has been a focus on the knowledge gaps, science and exploration knowledge gaps and capability gaps related to lunar volatiles, including water, but other volatiles as well. And so we actually created a website that's out there. It's at a NASA site, lunarvolatiles.nasa.gov, but it's an ISEG website. And the intent was to create kind of a repository for a lot of the knowledge that's out there. A lot of the scientific knowledge, and then also the technologies and capabilities. And in particular, we initiated a series of workshops, and some of you here may have participated in those. These were virtual workshops like this one. There was no physical gathering, but they were just conducted virtually. We did them over a set of 4 of them over a period of about a year, focused on different topics. So lunar data sets was one. What is the state of knowledge from the various missions internationally, and so what are the remaining gaps? Where to explore? So we had some focus on particular regions of interest that seem to be promising, permanently shadowed regions, for example, and how to explore different approaches to traversing the surface, sampling strategy, that kind of thing. We focused some discussion on prospecting instruments. We wanted to make sure the whole community is sharing that kind of information globally, because inherently we see this as a problem that does require sort of a long-term commitment and contributions from a variety of players. So prospecting instruments, and then we started some initial discussion on acquisition technologies. So we did that set of workshops and captured information on the website, and then with all this input that we've been receiving from the community, we had experts from around the world sharing their knowledge and information in these workshops. Sort of thought, well, the ball has been volleyed over to the agencies. Maybe the agencies sort of need to digest and think about, reflect on this data and see how it can apply to the robotic missions to the moon that are currently being planned, that have the potential to contribute to our understanding of lunar volatiles. And so we started a process, a dialogue amongst space agency reps to consider that information. And we're in the midst of that now, and in fact we're having some meetings this week about that. Say more about it. So this is, let me talk just a little bit more about the website, maybe just give everybody a quick tour of this. So actually, Ricky, can we show this website? It might just want to quickly show people what is there. No? Oops. Sorry. Okay. Oh, the top button on here? Okay. Oh, I see. If we could go to the, just show you what's here. Go to the workshops menu right there. I don't think I can control it, so Ricky's doing it for me. Okay, so there's the list of workshops, and the part. Scroll down a bit just so you can see some of the. Yeah, so this is one workshop 4. So we have. Just keep scrolling through. There's a variety of topics here listed, and all the presentations are available. This is prospecting instruments, where to explore and how, so forth. So, and there's also recordings of it. Our friends here at Survey recorded all of this in Adobe Connect, and there's some text files there, some PDF files on the summary findings. So there's a lot of detail there. It's a good resource. Maybe go back to the top, and I just want to show a couple other things. Over in activities, the activities menu. Oops, right there. And then just kind of scroll slowly through here. So we have some sampling of information from the different agencies, some of the lunar volatiles related missions that are being planned, and some of the instruments that are being developed. And so we kind of continue to update this. Okay, scroll back up one more time to the top, and I just want to show the library. Yeah, over to the right. Just click on that real quick. And so John Gruner has done a great job of sort of just compiling a lot of great references. You can scroll down here. They're topically arranged. Lunar polar environment, lunar water ice, NASA resource prospect, et cetera. So there's lots of papers and links to lots of stuff. So, okay. So anyhow, there's a good reference there, and we're using that within the agencies to inform our discussions. Okay, back to the PowerPoint. Great. Okay, so a little bit more about this dialogue activity that's going on. The objective is to try to bring some collective optimization to the suite of missions that are being planned. They were motivated by various reasons. A number of agencies focusing on the moon, focusing on, in many cases, on the lunar poles, but not necessarily in a tightly coordinated fashion. So can we improve that? How can we make the collective closure of strategic knowledge gaps more efficient and quick? So we're addressing things like landing sites. In some cases, the landing sites are already chosen, or there's some candidates. In other cases, it's still wide open for discussion. And so, we recognize on the one hand that, again, there are many motivations for these various missions, and I'll show that chart in a second. But to the extent that we can influence those to the mission planning to target high priority sites that may be complementary, so that various missions may, like I said, coordinate in a sampling approach or a prospecting approach by comparing the data from different missions. That's what we're in discussions about now. In addition to landing sites, the actual payloads and instruments, what complement of prospecting instruments is appropriate. First of all, we went through those workshops and collected lots of information on that. So how can we translate what we know about the ideal suite of instruments? How can we translate that into actually manifesting them on these missions, and again, in some coordinated, optimal way? And then various data sharing and science coordination of science teams. This can be extremely valuable. It's maybe a no-brainer, but to get everybody to be sharing their data, first of all, making the policy commitment to do that, to be working on common formats and accessibility to that data. Those are things we need to work through. And the science teams as well, coordination amongst the respective science communities internationally will be extremely important in terms of defining mission objectives and interpreting the data in a collective way. Common infrastructure, this could be things like a communications relay, who might provide that, or how might we go about providing certain services that could be equally valuable to multiple agencies. How can we work together, maybe in concert with the commercial sector, to again raise the water level for all missions and all agencies. This mission coordination dialogue team within ISEG is in the midst of a series of discussions on that, and you can see the participants there from all the interested agencies. Part of this process, we did engage the Lunar Exploration Analysis Group, the League. They compiled a team, including membership internationally as well, and provided some input to the agencies for consideration. So that's in fact again what we're in the throes of right now. This is the set of missions, and I think you've seen this before, but again, I think the message here is that there really are a lot of missions. Not all of these are to the poles, but many of them are, and there's some orbiters in there as well. So again, there's a lot of potential coordination here that we're aiming for. And I'll get to the League. Maybe I'll come back to this chart. I'll go ahead and just show the. Let me go to the League, and I'll come back to previous chart. This is a summary of the findings from that League team. I won't go through all of them, but I will touch on some of them. You can see finding number 2 regarding orbital data, a particular recommendation that agencies might want to further enhance the remote sensing data we've acquired already through several lunar orbiting missions, LRO and Chandrayaan and Kaguya and so forth. What we don't have are really high resolution, at least 5 kilometer or less per pixel measurements from neutron spec and neutron devices. So if there's a way, and this would require getting very close to the surface with an orbiter, so some highly eccentric elliptical orbit, getting down close to the surface. So that's an opportunity there that agencies are considering how we might fulfill. Another orbiter, the KPLO mission, that's the Korean Pathfinder Lunar Orbiter mission, is part of our planning, and will provide some critical data. But some of the other findings here more general than finding number 5 on mission distribution. The idea that indeed a good way to close these knowledge gaps is to fan out across the polar regions to multiple sites, as opposed to necessarily. It's not the case that there's a clear preferred site on the South Pole or the North Pole that provides obvious benefits or advantages over any other place with regard to potentially utilizing lunar volatiles. Instead, what we have is we have some data that shows initial information about the distribution of volatiles, but there's a lot more both more or higher resolution orbital data, but certainly ground truth needed to really characterize that. And so in the meantime, the situation is such that we'll probably end up wanting to explore multiple sites and compare at a first order, what the concentrations of volatiles, the local horizontal and vertical distribution, what are they at different sites, and use that as the first step in a broader effort to characterize and compare landing sites. So again, these are just recommendations from the League, but these are the kinds of considerations that the ISEG is discussing now. So multiple sites, and in finding number 7, coordinated prospecting. The suggestion is that we execute this through, obviously, in a coordinated way, but also in a phased way, recognizing that there might be, like I said, sort of a first pass where some X number of sites, South Pole and North Pole, are assessed. through a series of coordinated missions. And through data sharing and analysis and hypotheses and updating and refining our knowledge, then we might go back for a second phase, a more comprehensive characterization in which we home in on a narrower field of sites. So at this point, we're just really having these long-term strategic discussions, but it's important to have at this early stage in order to certainly inform the missions that are already in the planning stages, and maybe even inspire the definition of some new missions. Let's see, and then finding number 9, essential measurements. There's a list of particular measurements that are sort of the high priority ones for purposes of characterizing volatiles, and then finding number 10, some complementary measurements, so sort of some high priority and then secondary, but also important measurements. So again, this is informing potential instrument selections. And again, it's just a strategic conversation at this point, but I think it's timely. Finding 11, technology development. So it points out rovers in particular, could be instruments or other systems as well, but to the extent that there are high priority gaps, that we're having those conversations as well. Where should technology investments be focused on? There's a series of findings, 12, 13, 14, on data sharing. Again, very, very important. Finding 15 is on integrating sample return and analysis efforts, and the last findings there on coordination amongst the investigation teams. So these are the kinds of points that we're focusing on in the multilateral discussion. Oops, I didn't mean to do that. There we go. Let me now finish. This is so slightly. Different topic. There we go. This is just to give a sampling of some of the thinking within NASA that can influence or form part of the overall international picture. There's been some references already to some of the partnering that we've done at NASA. So let me just kind of lay that out. NASA's been anticipating opportunities to work with the commercial sector for lunar transportation of payloads for some time. And we've recognized that on the one hand there's a burgeoning supply of lunar landers from the private sector, in part inspired by the Google Lunar X Prize, but more generally inspired by I think just a newfound interest in the moon and a recognition that some of these spacecraft technologies might be achievable to actually build small spacecraft with small entrepreneurial teams. So NASA saw this and recognized an opportunity to improve maybe the efficiency and cost of our access to the moon. Instead of being resigned to dedicated missions only to getting to the moon, this would be an opportunity to sort of acquire access to the moon on a payload by payload basis, and it lowers the entrance barrier or challenge to accessing the moon. And of course, that's good news for agencies. It's also good news for the private sector, as we talked earlier on the commercialization discussion. By lowering entrance barriers, you potentially widen the field of players who might represent demand, whether they be small companies or even universities, what have you. So we're talking, potentially single-digit millions of dollars to access the moon with a small payload instead of the traditional barrier, which is probably hundreds of millions of dollars to get anything to the moon. We've chart here is a reference to a couple of requests for information or RFIs that NASA's put out. One was focused on payloads. The NASA posture on lunar payloads has been, there are a lot of strategic reasons to want to send payloads to the moon. They're driven by in some cases by the science community and our science mission directorate through the decadal surveys. So there's interest in geophysical networks on the moon, on sample return missions, and on volatiles analysis for scientific purposes. From an exploration standpoint, all of the ISRU-related motivations that John Gruner just talked about, and certainly Mars forward technology demonstrations on the moon. So there are a variety of motivations to send payloads to the moon. From a consideration of the commercial potential here, and the reason we went out with these RFIs, we recognize that probably this market is if it's going to be successful, we need to start small and grow gradually. So we might anticipate initially individual instruments and a few kilograms at a time. But the hope is that this market can be properly stimulated so that there's opportunities to use commercial assets to send payloads ranging from a few kilograms to hundreds of kilograms or tons even eventually. So there's some, let's see, we received a variety of responses on the types of payloads that might be available in the next few years. And the second RFI on the transportation services and payload services was complementary to the payload one. This one is then asking what exists out there, what emerging capabilities for end-to-end services, all the way from Earth launch to landing and related payload services, what's out there. And so we got, I think, 14 responses, and with a variety of capabilities and maturity levels. So again, it's an emerging market, and it's informing NASA's plans now to organize some procurements. And so we are actively planning a payload services solicitation effort sometime in 2018. So stay tuned for that. But I think the message is that we see there's probably a long list of payloads and that NASA can foresee investing in and procuring services for. So we're testing out sort of a new market. It's an experiment of sorts, but we're hopeful that this will pan out, and we look forward to working with industry on this going forward. So that's all I had in terms of presentation, but I'm happy to take any questions.
Okay, thanks, Nantel, very much. Are there any questions in the room for Nantel?
Hey, Nantel, Brad Bailey, and I see up there about the RFI response from December 2016, and I'm sure most people in this room are aware there's a lunar landing site workshop that's ongoing in the January 10th through 12th timeframe, where we have solicited from the community recommendations for places that they think we should be going for scientific return, and with all of that leading up to the possibility of transportation services getting to the surface. When do you expect to have the data from that RFI response available, and could you potentially come present that at that meeting so that we would be more fully aware of what the community thinks from your RFIs?
Yeah, the thing is, maybe we should have done this, but we didn't explicitly provide instructions, or rather, we didn't specifically stipulate that the RFI responses would be made public. So there's some proprietary concerns and sensitivities there. So that's why we haven't released those individual RFI responses. We could talk offline about ways to maybe work with the community. It could be we could go back to the RFI responders and just ask them and see if we can get clearances to share that information. from a NASA perspective, we're happy to promulgate this information, but there are some concerns about proprietary information. So let's see what we can do, Brad. Maybe there's. Yeah. Okay. Yes, sir.
How many payloads and how much mass are you thinking about in that RFP?
I'm not sure how much I can really say yet. It's procurement sensitive for one, but it's also in play. I think those questions are not fully settled. But I mean, in general terms, like I said, we would start with smaller payloads for two reasons. One, what we see capability-wise out in industry that's realistically ready to go in the next few years will be relatively small, tens of kilograms at a time. But eventually, we see a very high ceiling for this, and our interest again is a long-term one. Our interest in access to the moon will not is not likely to wane. It's likely to grow. So we foresee a procurement that would be extended in time for a significant amount of time, and would accommodate larger payloads as the supply and the market dictates. The other, independent of whatever the market's capable of providing in terms of end-to-end services and landers, service and transportation services, launch vehicles and landers together, independent of all that, just from a NASA risk standpoint, again, I think we want to dip our toe in the water first, putting at risk smaller and simpler payloads at first, and then growing into it. Again, as I talked earlier in the previous talk about the shared nature of risk here, we may find ourselves in a position to fly NASA payloads on the very first mission of, if not a launch vehicle, then at least a lander, or one of the first. So as time goes on, that risk diminishes and confidence grows. So for both of those reasons, I think we can imagine ourselves starting small and growing into it.
Thanks.
Hi there. Kit Carson with OSE Rocket Tooling Systems. I had a question about the cost sharing here on the Moon Express and Astrobotic Technology cost sharing projects that you have here. Where can I find some more information about that? And so is that a cost sharing structure? Is that a matching, or how would that work for smaller companies like my own where I don't have $500,000 to match something in order to compete with the larger companies like some other people might?
Yeah, I don't have any more detailed information other than what I'm showing here. But you can contact the companies directly, and they'll be happy, I'm sure, to give you more details.
So here's a question for you. Is the European Space Agency pursuing any programs or projects that could result in the availability of a commercial lunar lander?
I think the short answer is probably yes, but I don't want to speak for ESA. I don't know if we're putting them on the spot. As you said earlier, ESA's, I think it's fair to say they've been studying commercial practices and have shown increasing interest in recent years, but I don't want to speak for them. I don't know.
Bernhard Hufenbach from ESA. Yes, that I can confirm that. We are just in the mission formulation phase. The formulation of a mission, which is a mission to demonstrate ISRU technology on the moon, and we intend to procure the payload delivery and the operations commercially. So we are testing the market in Europe. We also have various commercial partners who approached us for supporting the early missions in the field of communication and lander delivery service, payload delivery service. So yes, we're looking at options to nurture commercial service for lunar exploration.
Okay. Any final questions for Nantel or observations? Okay.